Hi, everybody. Welcome to the notes for lesson 15.3, which is on dividing polynomials. So we're going to review just a few basic things. So in this first example, there's no x term, but if you wanted to write one in, it would be like that. So this means it is 0 degree, and we call this a constant type of function. And in this case, there's only one term, which is called a monomial. Hopefully these terms sound familiar from Algebra 1. In this case, the degree here is 1. So this is first degree. And whenever it's a first degree function, it's typically linear. And this has two terms, so we call this a binomial. In this case, whoopsies, I think this is supposed to be a plus. It's a little typo here. This has degree 2. So this is second degree. And whenever we have degree 2, those are quadratic functions. And in this case, there's 3 terms. So we call that a trinomial. In this case, it has degree 3. So this is third degree. And whenever it's a third degree, we call it a cubic. And then notice there's more than 3 terms. We don't do a quadonomial or something weird. We just say polynomial with 4 terms. So that's all you need to do for the classification. Over here, it's fourth degree. So we call those quartics. In this case, there's 3 terms. So it's a trinomial. And this is all for classification. So when I give you a polynomial and I ask you to do the classification, you can tell me the degree, you're going to tell me if it's quadratic, etc., and how many terms there are. In this case, degree 5, so 5th degree. And those are called quintic. And then we don't really go higher than that with the words. You could try to get fancy, but we're not going to. This is a polynomial with 1, 2, 3, 4, 5 terms. And sometimes I write poly just to be on the short side. All right, this is just a little review of how we do long division, because we're going to be doing long division here with polynomials. I don't want to do all of these. You can do these yourself. I'm going to go over just this one. So 1728, when I divide by 12, so this is just a reminder of how we do long division. What are the steps? So we try to figure out how many times 12 goes into this first number. Obviously, it doesn't go into 1. It goes into 17. It goes into there 1 time. And then I take this and I multiply by whatever's on here on the outside, and I write it underneath. And then I write a minus sign. I subtract. So I know you guys know how to do long division. I mean, this is like 4th grade math, but you guys don't remember the steps. And if you don't remember the steps, then when we do it with polynomials, you're going to be confused. 17 minus 12 is 5. Then you bring down the next term. And then once again, I see how many times 12 goes into 52. So 4 is the most I can do there. I multiply, I get a 48. And then you minus, right? You minus, and then you bring down the next number. And then 12 goes into there 4 times, 48. And this has remainder 0. So the answer is 144. Okay, we're going to do the exact same thing, but with polynomials. So that is when we're going to do long division. So we're going to go over that. And then after we do that, I'll show you another way to do division, which is synthetic division. Synthetic division, in my opinion, is a lot easier, but it doesn't always work. You have to have the ideal conditions for it to work. Long division is always going to work. It's just a little bit longer of a process, but no biggie. We can do it. So just like in here, 1728 is the dividend, goes inside the little line, the little division thing here. And then 12 is the divisor, goes on the outside. So this is the dividend. It goes inside, just like we did the ones with numbers. and the divisor goes on the outside. So this is like my 12, and this is like my 1,728. All right, so let's go through how to do this. So what we want to do is we want to look at this first term here and see how many times it can go into 5x cubed, just like how many times 12 can go into 17. I'm going to keep referring back to this one so that you see the idea here. So what do I need to multiply x by to get 5x cubed? Well, it's going to be 5x squared. So remember, once we have the number up here, what did we do? We multiplied by what was on the outside. So we're going to do the same thing here. Now, the difference is there's two terms. So when you multiply, you're going to multiply by the x and by the -1. So 5x cubed minus 5x squared. And one little tip that I forgot to say when I set this up, this is 3, 2, 1, 0. If I'm missing one of these, like let's say I didn't have an x squared, I would just put some space there or put a 0x squared as a placeholder to make sure when you combine like terms that it all works out really nicely. Okay, so once I have the 12 here, notice I subtracted. I did 17 minus 12. So I'm going to do the same thing. I'm going to subtract. But when you subtract, there's more than one term that you are subtracting. So 5x cubed minus 5x cubed is nothing, right? It cancels. 3x squared minus a -5x squared. So these two negatives make a positive. So then I get 8x squared. And then you bring down the next term. Okay? I'm going to use a different color for this one. So now I'm going to see, what do you multiply x by to get 8x squared? Well, I'm going to multiply by 8 and an x. Same thing, I'm going to multiply again to go down here. So 8x times x is 8x squared minus the 8x. And then remember, you're going to subtract. When you do that, please put parentheses so that you don't forget to distribute this negative. 8x squared minus 8x squared is nothing. -4x plus 8x is a positive 4x. And then once again, bring down the next term. I'm going to use a different color for this last bit here. So now I want to see, okay, what do I need to multiply x by to get 4x? Well, it's going to be a plus 4. And then again, I'm going to multiply. So I'm going to get 4x minus 4. And then when I subtract, that's 0, that's 0. So I have a remainder of 0. So my answer is 5x squared plus 8x plus 4. That's how many times x minus 1 goes into this long polynomial. Okay, now please pause your video and try the next one. Pause your video and try this next one. Okay, welcome back. I'm hoping that you paused and you gave this a try. This is not missing any terms, so when I set it up, I just write them all down. If, for example, I didn't have an x squared or I didn't have an x, I would just put a 0 as a placeholder. All right, look at the first term here. What do I need to multiply x by to get x cubed? That would be an x squared. Then I'm going to multiply x cubed minus 2x squared. Minus, that's nothing. This gives me 3x squared. I'm going to bring down the next term. Okay, once again, what do you need to multiply x by to get 3x squared? A 3x, and then I'm going to distribute that guy. So I get 3x squared minus 6x. Don't forget the parentheses and the minus. So that goes away. This is a plus. And so -11 plus 6 is a -5x. Bring down the next term. Different color here for you. X and a -5x. So you have to multiply by a -5 to get that. Distribute again. So -5x plus 10. And we're so nice that the problems that we made for you here have 0 remainder. Doesn't that make your life easier? All right. So there it is. There's the answer to that one. So that's long division, okay? So now we're going to go over synthetic division, which is on the back side of this or second page, depending how you printed it. All right. So for synthetic division, what you want to do, the key with synthetic division is that what you are dividing by has to have a power of 1. Okay? If you're trying to divide by something like x squared or whatever, it doesn't work using synthetic division. You have to do long division. So this only works when the degree is 1, right? The degree of the divisor is equal to 1. Okay, if not, you have to do long division. You don't have a choice. Okay, so the way this works, let me set this up for you. So we put the opposite of this number in here. Okay, opposite, that's what goes in here. And then inside here, I'm going to put the coefficients of the dividend. Okay, so, and if you don't have something, you're going to put a 0. So 3, the next one's a -2, and then the next one is a 5. Okay, so now let me show you the steps. The way synthetic division works, leave some space here when you set this up. The first term always comes down. The first term always comes down, and then you're going to multiply. 3 times -1 is a -3. I'm going to put it here, and then I'm going to add these. And then I'm going to repeat. -5 times -1 is a -5, and then I'm going to add. Okay. Then, break this up here a little bit. Working from left to right, or right to left, rather, whatever this last number is the remainder. And then these are the coefficients for all the terms. So this is the constant term. This is the x term. If there were more things, it would just go in order. Okay? So that means this is 3x minus 5 and remainder. Oh, whoops, I messed up. -5 times a -5 is a +5. So my remainder is 10. Good thing we weren't in class. You'd all be chatting me up, telling me I made a mistake. Okay, so it's going to be 3x minus 5. And then the way we deal with remainders, when we did the long division, you didn't have any remainders, but it would be the same thing. You put the remainder over the divisor. That's how you write the answer. Okay, so that is how you do synthetic division. Okay, I'm going to go over this one with you one more time, and then I'm going to have you try one of these, and then I want to go over this one. This one's a little different. Well, it's not different, just that you have to be careful here with this. All right, here we go. The opposite of this -4 is what goes in here, which is a +4. And then I'm going to do my coefficients. This is a 1. This is a -1. There's no x, so you would use 0. So I would have a 1, a -1, a 0 because there's no x, so it's 0, and then -48. Leave some space. First number comes down, and then we're going to multiply. 4 times 1 is 4. You're going to add these. This is going to give you a 3. 3 times 4 is 12. Add. 12 times 4 is 48. Add. And then let me review how we find our final answer here. This is always the remainder. This is the constant term, the x, and the x squared. So I'm going to have a 1x squared plus 3x plus 12, and there's no remainder. So that's my answer. Okay, so right now, why don't you pause the video, and I want you to try this one. Don't try that one yet, because I'm going to go over that. Try this one. Pause the video and try that now. Okay, hi, welcome back. Hopefully you guys all did that. I'm going to do the opposite of this guy, and I'm going to put my coefficients. A 2, a 3, a -6, and a 5. There's nothing missing. Okay. So I'm going to bring this down, which is a 2. 2 times -3 is a -6. Add, and then multiply, and then add, and then multiply, and add. Okay. So this is my remainder. This is my constant term, my x, and my x squared. So my answer is 2x squared minus 3x plus 3, and then minus a 4 over x plus 3. If that was a positive 4, it would be a plus 4. Hopefully you guys got that right. Okay, let me show you how to do this one. This one's a little different. Instead of just doing -1, I have to make this equal to 0. So when I solve this, I get x is equal to 1/2. So that is what I put in that little box area here. I put 1/2. Because when you set these guys equal to 0, you get the opposite. We're getting the opposite. Put the coefficients, a 2, a -3, a -1, and a 1. If you want to pause this now, you can try to do this one more time and then come back and see. Okay. So for this one, if you didn't pause it, then we're just going to go forward. If you paused it, welcome back. I bring this down. 2 times 1/2 is a 1. And then I add these. -2 times 1/2 is a -1. Then I add these. -2 times 1/2 is a -1. Okay, great. So then this is the remainder, the constant, the x, and the x squared. So I have 2x squared minus 2x minus 2, and no remainder. Awesome. Okay, the last two on here are review from what we've been doing, except instead of giving it to you in factored form, it gives you one of the factors. So the idea here is that I have x plus 3, and then I have all this other stuff. Well, actually, that's not true. This right here is going to be factored into x plus 3 and then something else. And I don't know what that something else is. So the way I'm going to fix that so that I can get it into factored form, which is what we have been doing. So this is not in factored form. It gives you one of the factors. And then when you divide this by that, it gives you the remaining portion here that you can then factor. Then it's exactly like what we've been doing. So I'm going to take this and I'm actually going to do synthetic division on this one. Change my mind. I'm just going to set it up for long division, but why? Might as well do synthetic. So -3, and then this is a 1, 1, -9, and -9. I bring down the 1, multiply, add, multiply, add, multiply, add. So constant x, x squared. It's got x squared minus 2x minus 3. So that means that this part here now is going to be x plus 3. And then this is how many times it goes into it. And then I can take that. I can do a little diamond method so that my final factored form is this. And now that I have it in factored form, it's exactly like we did before. It is exactly like we did before, where this is going to be an x cubed, right? And it's a positive x cubed, so I know it's going to be the general shape with end behavior like that. My x-intercepts are -3, 3, and -1. So 1, 2, 3, 1, 2, 3. So -3, 3, and -1. Then I need to find my y-intercept, where I plug in zeros for x. Remember, we did this the other day. So -9 times 1 is a -9. So somewhere down here is going to be my y-intercept. So remember, my general shape, I know this goes down here, up here, and then I have to try to figure out what's happening in the middle. There's no multiplicity, so I know it's just going to come up, go right through there, and then back up there. So that's my graph. Okay. Why don't you guys give this one a try? Pause the video, try this, and then we'll go over it. That's the last bit we're doing here. All right, welcome back. So we want to know what all of this is. Okay, if I take this polynomial and divide by x minus 1, my answer will be this, so that if I were to multiply and distribute everything back, I go back to the beginning. Okay, so I'm going to do this one with synthetic division. So that's a 1. Sometimes you have to use long division. There's no missing terms here, so that's a nice touch. So the 1 comes down, I multiply, add, multiply, add, multiply, add. So this is my constant, my remainder, my constant, my x, and my x squared. So that means that my answer for this is x squared plus 3x minus 10. And then I have to factor a little bit more here so that I can get all my x-intercepts. So this is going to give me x plus 5 and x minus 2. Awesome. All right. Now we know this is going to be x cubed. It's positive. So there's my general shape. My x-intercepts are 1, negative 5, and a 2. There's no multiplicity here. And my y-intercept, I plug in zeros for x. So I get positive 10. Okay, so let's graph what we got here. So we have 1, 2, and 1, 2, 3, 4, 5. And y-intercept of 10 somewhere up here. I know my end behavior, this goes down, this goes up. So in between, this is going to go through the point, down through the point, and then back up through the point. Okay, there's no multiplicity, so that's all you do. All right. I hope that was all clear. See you next time.